Today we are going to do section 2.2, but we're only going to do the first part of it, and then the homework assigned in this video, it also refers to only the first part. The reason is because this section is extra long and it consists of two concepts that's not even directly related. So I feel that it's better to, if we just pretend that this one section is actually two sections and handle it accordingly. So for this section, then we're only going to do how to solve equations, and then the next section will manage all the about equation of lines. Okay, so let's first let's go to page 100 where we have let's look at example 1. You probably already know how to do some of these, solve some of these equations, but solving equations is basically all you ever do in math from this point on. So it's very important to be extremely good at it. Okay, right. So let's look at this. To solve equations, let's look at example 1. We have, here's example 1. Where we have a quick short equation to start with, 2x plus 7 equal to 19. Now to solve any equation, what we do is anything that we focus on x, okay? The variable is what we're looking for. Now anything that isn't a variable, we're going to kick it over to the other side of the equation. Now in this case, there's a plus 7 there, so we're going to kick it over here. And when you do, you change the sign. Okay, as your book, the reason for that is because you're actually subtracting 7 from both sides. But the way we remember it, we'll just remember we'll kick it to the other side by changing the sign to the other one. In this case, we will have minus. Okay, it was plus here. We'll kick it to the other side and call it minus. That's a 9. Okay, and then 2x is still here. All right, so that's the first step. We'll do the math here. That becomes 12, right? And then the next thing we're going to do is there's a 2 attached to x, and we need to isolate x from everything else that's stuck to it. Okay, so then we are going, that is, we'll want x alone on the side. That's how we solve the equation, is get rid of everything around x. So first we kicked 7 to the other side. Next we're going to get rid of the 2. Now being that 2 is being multiplied, we're going to divide it out. So we'll move, which means we'll move the 2 to the other side to the bottom of the division line. That is now, so then x equals to move the 2 to the bottom, draw the division line, and write down the 2 on the bottom. Okay, that's how we will do every single case. Anything's being applied, that is, anything's being plus or minus, kick it to the other side by putting in the opposite sign. Anything that's being multiplied or divided, we'll move it to the bottom of the other side. Okay, by moving the 2 to the bottom. So then that is our x, which turns out to be 6. Okay, yeah, see, that is the right answer. So please do example 1 as part of your homework. And I already did this, so just don't look at it and see if you can reproduce this stuff yourself after the video when it's slightly out of your memory, right? So that's how you can remember. That's how you can get good at algebra and good at math in general, is by redoing all the examples in the book that I go over or tell you to do. By practicing it, you can get extremely good, because if you have a problem you can't remember, the book tells you how to do it right there, right? It's like it's like rewatching your video for when your coach tell you how to throw some ball a very specific way. Now if you forget it, just watch the video and do it again. Okay, and when it comes to math, practice is what makes perfect. So next, let's look at example 2. Example 2 is the same deal here. Let's write this thing down. What is that? 4x minus 3 equal to plus 12. Okay, 12 equal to 15 minus 5 times x plus 6. Now that is with this, the first thing we're going to do, there are a bunch of parentheses here, so we're going to simplify everything first. And so simplifying, remember how you multiply stuff, okay? To multiply is like shaking hands. You will multiply what's outside. The guy outside will shake hands with everything on the inside of the parentheses. People in the parentheses are the same group. They don't shake hands with each other. Only the guy outside shake hands with each person in here one time. Okay, and then any negative sign is attached to this. That is, minus is the same as minus -3. So remembering that, let's do that. So 4 times x, that's equals 4x, and then 4 times -3, that's minus 12. Okay, and the plus 12, we'll copy that down. And for now, and then there's 15, okay? And next, let's look at this. This is a -5, okay? This number, this sign here is attached to 5. So minus 5 will be multiplied by x, which becomes minus x, okay? Remember, the guy outside will shake hands with everybody on the inside one time. Okay, and each thing in here is considered one item. So minus 5 will multiply by x, and then minus 5 will multiply by plus 6. So negative times plus is negative. The same sign is multiplied together is positive. Different signs multiplied together is negative. So minus 5 will multiply plus 6, which end up being minus 30. So now that we have that, and so the next thing we will clean up a little bit. The numbers, see, over here we have 15, okay, minus 30, so that is equal to minus 15. I'll write that down here. And then the minus 5x, we'll keep it this way. And over here we have minus 12, and then plus 12, that's 0. So we'll write down the 4x over here. So at this point, our problem has been somewhat simplified to be kind of similar to this, except we have 2 x's on each side. We want to put all the x's on the same side, preferably the side that has a positive x, okay? This is negative here and is positive there, so let's push all the x's on the other side. Whenever you move something across the equal sign, you will change its sign, like I said before. See, you moved 7 to this side by changing the sign to -7. We're going to move the minus 3x across the equal sign by changing it into a plus. So this side becomes 4x plus 3x, like this, okay? Because we'll move this thing over. The minus 5, we haven't moved it, so it stays the same because we haven't done anything to it. So that it will equal to, so eventually we get, let's see, did I make a mistake in here? Let me check. Oh yeah, there's a mistake in here. Let's see, because this says minus 5x. I don't know why I suddenly changed it to minus 3. Let's not do that, okay? Don't repeat my mistakes. So so this is actually minus 5. See, it's minus 5. I don't know why I wrote down 3 for no reason. So kicked it over here is a plus 5. So we have 5. Okay, and then at this point this will be equal to 4 plus 5 x, 4x plus 5x. That's like 4 oranges plus 5 oranges. That is 9 oranges. And then so at this point, then we will divide both sides by the number 9, just like here. See, here we'll move the 2 to the other side on the bottom of the division line, okay, because it's multiplied. So you move it down. So the same thing here, then x equal to 15, move it down, move the 9 to the bottom of the division line on the other side. That would be your answer. And this can be simplified further by canceling out the 3 because there's a factor 3 in each number. So we have 5 over 3. And that is the answer to example 2. Except there's I forgot the minus sign. Look at that. Okay, so let's not forget the minus sign. There's a minus sign there. And there is the correct answer. See, that's why it's important to work through the examples yourself. That way, if you make a mistake, then you can compare it directly and know exactly where you messed up. See? And well, that's if you mess up. It happens, okay? Some people don't mess up as much as I do. I tend to mess up a lot on this type of thing, especially. So, but it's okay, because if you mess up, just find your mistake and fix it, okay? And so that's how we would do this. Now that's example 2. Now next, let's look at example 3, will we have a more complicated situation. Example 3, this is on page 101. So please turn to page 101 and let's look at example 3, which says something like that. So 7 over 2x, and now well, x is on the bottom, okay? That always confuses people, but we actually are gonna do this the same way we always did, equals to 22 over 3, all right? So how are we gonna do that? There are a couple of different ways to do it, but the most common, I'll just do it how I would normally do it, okay? So let's say we have this situation, and what we're gonna do is, as always, when you see two fractions, we'll do the common denominator situation, which this becomes 6x, will be the least common multiple, okay? So we have 6x. I shouldn't draw a single one. Okay, let's keep it at 2 of them. So let's turn everything into 6x. 6x, okay, minus 6x. This side doesn't change. 22 over 3. Now, if we turn everything into 6x, for that to happen, this got multiplied by 3, and so does that one, okay? Yeah, so we have 3 times 7. I'll write it down like that. So I'm multiplying both top and bottom by 3 in order to achieve the 6x effect, because I want to add them all together. So, and then this one, to become 6x, we need to multiply by 2. So, right? So the dot means multiply, okay, in algebra, so that we don't confuse the multiplication sign with the x. So we have this situation here, and then this becomes 6x. Okay, that is 3 times 7 is 21, and 2 times 5 is 10, and we do the subtraction. Why did I write down 5 here? I mean 6x. We have 6x on the bottom. Okay, 6x. So we have 21 minus 10 in the numerator, which gives us 11, which equals to 22 over 3. All right, now at this point, there's another trick that I want you to remember, and I don't know if you want to call it a trick. It's called the cross multiplication. If this is true, that is if A over B equals to C over D, which is our situation here, where A is 11, okay, B is 6x, x, etc. We have a rule that's called then A times D this way, okay, it's the same as B times C. In doing this, you got rid of the division lines on both sides. So we're going to apply this rule. This is one of the basic algebraic rules. Okay, if you don't remember it, the time to remember it is right now. All right, so please memorize this, and then we're going to apply that principle. So then 11 times 3 equals to 22 times 6x. All right, so then as a result, then as we are going to move all these numbers to the bottom of the division line, okay? Because we want to isolate x. X is on this side, but that changes nothing. We have 11 times 3. We're going to divide it by 22 times 6. The reason is because, as I mentioned before, to get rid of the number that's attached to x, we need x by itself. So to kick this thing off, we need to move it down the equation, across to the bottom, okay? Kick it to the bottom of the division line. The same thing here. We have 22 times 6. The fact that it's a big number means nothing. We'll kick this thing down the division line. And then at this point, we isolated the x, okay? So x is this thing. And what is that thing anyway? We can, at this point, it happens to be conveniently cancelable. So 11, we'll cancel 11 with 22. That gives us 2 here, right? Cancel 3 and 6. That also gives us a 2. So together, x will be equal to 4. And 1 over 4. Yeah, that looks a bit bad, but if you look at your book, then it will make sense. Yep, see, that's what it says. It's example 3. The answer is 1 over 4. And that is how you solve equations. Now, remember, this is extremely important to know inside out. Okay, this is solving equations is the as I mentioned before, that chapter 1, you need to know chapter 1 inside out. Now, chapter 2, the equation part is the last thing you need to know in the entire algebra, that you need to know this inside out. That is, you need to be able to do this stuff in your sleep, okay? In this section, that is 2.2 part 1. And I will refer to this section off and on throughout this entire course. And after this course, in trigonometry, precalculus, all those things, okay? It will be extremely dependent on your ability to solve equation. And to do that, you just have to remember this stuff. Okay, so it's extremely important that you know how to do this. So please practice it again and again if you have to, until you can grasp this thing just tightly and not let go. You know, like a baby's, like Hercules squeezing the snake's dead. The same idea. You're going to grasp it very, very tightly and hit this hard until you know this stuff inside out. Okay, but this is the last thing that I can think of in this whole course, that you need to know it that well. And because the reason is because we have to do this all the time from this point on for the rest of your math. Any math that you're going to learn, you're going to be doing this. So so next, let's look at example 4 after I clean off the board. Next, let's look at page 102, example 4. We have a problem like this. We're going to approach this equation in a slightly different trick. Is what we're going to do is we're going to multiply everything by 2x. Why by 2x? Because 2x is the least common multiple of everything in the denominators. Okay, so by multiplying 2x, we can knock out every single denominator, because fractions are kind of a pain, so we'll get rid of it. So let's do that. We're going to multiply 2x on both sides. Okay, so we'll write it this way. So multiply 2x and then multiply 2x here, and so that everything will so that all the denominators will disappear. First, if you multiply 2x here, okay, the 2x and the 2x will cancel out, and we have a nice little 7 left. Now over here we have 2x times this thing. The x will cancel out, but the 2 won't, so we'll have 2 times 2. So that's what we have left, is 2 times 2 for the first term. Secondly, the negative, we'll write down the negative sign, okay, and because that's for positive and times negative, so it's still negative. Now this thing, we times 2x and then multiply here, where you cancel out the 2, because the 2x is well, anyway, so this is in the numerator. Okay, anything without a number on it is the same as dividing by 1. That's why we're doing this. Okay, so so we have 2x canceled out the 2, so we only have x left. So we have x times negative 3, so we have the result is minus 3x. So that is, so we end up with this thing. Now this thing is much easier to do. We will, to make this make sense, we have a minus 3 here, okay? I like to move the term with the x to the other side of the equation and make it positive. Remember, anytime you move stuff across the equal sign, you change the sign. So this thing, I'll move it over and call it 3x. And then this one, we have 4. 2 times 2 is 4. And then we'll move the 7 to the other side because x is on this side. Okay, we'll kick everything else that isn't x on the other side. So it becomes a minus 7. Now the next step then, so 4 minus 7, that gives you a negative 3. And then, so this is 3x. And at this point, we'll push the 3 to the bottom over here. Okay, so that x equal to minus 3 divided by 3, because I push this 3 across the equal sign, which means I have to push it down below the division line. Okay, sorry. So that will be equal to, so x equal to minus 3 over 3, which is equal to negative 1. And that should be our answer. Right, so that is the answer to example 4. We don't have to do it this way. We can do it the same way we did in the previous example, which would be, which I'm going to do that here as well. Now, if we were to do this problem, example 4, the way we did before, what we did would be, we found the common denominator for everything, which is 2x. Okay, so let's rewrite well, we don't have to rewrite the problem, but let's do it. Okay, let me rewrite the problem here. So using the previous approach, which is we have x here, 2, and 2x. So we'll make everything into 2x, okay? So then we becomes, to turn everything into 2x, in the denominator, what we're going to do, that we have to multiply 2 on top, so that this is the same as that thing, right? And then here, we need to multiply x, 2x. That's a 2 there. Let me, okay, so that is, we need to write x there too, to be fair, right? So because this is the same as that. And then the last term, we don't have to do anything because it already has 2x on the bottom. So at this point, we have then the whole thing that has the same denominator. So then we can then ignore it, basically, is what that means. So we have 4 here, okay, minus 3x equal to 7. The denominators are the same, so which means that we will multiply by 2x all the way across, or just pretend that it doesn't exist. So anyway, so once the denominator is the same in the equation, we can totally ignore it. So that it's like factoring it out. So so we just have this thing left, okay? And at this point, we do the same thing we did before. Let's move the x's on the other side, so that it's positive. Because I like my x's positive, okay? But you don't have to do that. You can just leave it here and do the division anyway. And then, so with this side, we have 4 minus 7, okay? I move the 7 across the equal sign and by changing its sign. So then this will become negative 3. Right, equal to 3x. So then push the 3 down to the bottom, and like we did earlier, to bottom of the division line, push the 3 down here, so that gives you x equal to minus 1. Well, yeah, so that is, so as you can see, we can do this problem 2 different ways, and you might wonder which way is better. Either way is good enough, okay? And it's just 2 different ways to skin the cat. Okay, there's more than one way to skin the cat. I don't know why people want to skin cats back in the day, but that is a saying. So let's move on to example 5. Now we are solving a rational equation, and we need to do something. Okay, here's our rational equation. Let me clean off my board. Well, I forgot to mention that please make sure that you do example 4 and 3 to 1, etc. Yourself, okay? After you watch me do it, it's very important that you do it yourself and make sure that you know how to do it. That you're extremely good at doing this kind of thing. All right, so next let's look at example 5, where we have the equation, what is it? 1 over x equals to 1 over 10 minus 3 over 4x. I think we're still on page 102. Okay, but we immediately flipped over to the next page. We're going to solve this thing. Now, how are we going to solve it? Well, we're going to use the method we did earlier, which being that there's a 4x here, right? We're going to multiply it by, well, the least common multiple of everything, x, 10, and 4x. And the least common multiple would be 20x, okay? So let's multiply it by 20x. They'll knock every single denominator out, okay? So let's multiply everything by 20x. 20x here, write it down. That's an x. Okay, and then 20x here, the same thing. We'll multiply both sides by 20x, okay? And what happens when we did that? So then the x, remember, the 20x is the same as 20x over 1, okay? Any number is always over 1. We just don't write it normally. So you multiply this fraction, then x and x cancels out, okay? And so we have just 20 over here. And then this one, we have 20 times, the 20 cancels out with the 10, and that gives us 2. And then the x will stay there, so 2x. And then the 20 cancels out the 4, and the negative sign is still here. We'll write down the 3. 20 cancel out the 4, that gives us 5. Okay, and the x's cancel out, so we got nothing left. So that is what we have left after multiplying both sides by 20x. And it's okay to do that, remember, because we're doing doing the same thing to both sides of the equation, so the equation doesn't change. Its quality doesn't change. That is, they're still equal. Okay, so having said that, then let's let's kick this thing to the other side, okay? Because our x is on this side. Oops, why did I write 3? It's 2. So our x is on this side. 2x is on this side. Then we'll kick this thing is 15. Kick it to the other side. It becomes 20 plus 15. Am I right? Give me a second. I might have made a mistake in here. No, I think it's okay. All right. So then that is 35, right? So that's 35, and we'll push the 2 across the equal sign to the bottom of the denominator. Okay, draw the division line, push the 2 down. So 2 is down there now. And then, so x is by itself, okay? Anytime you push something multiplied by x, and you want to get rid of it, you will push it to the other side, but at the bottom of the denominator, okay? Straight down like this. And then once you do that, then that is your answer. As you can see, according to the book, that is what the book has. So we must be right, okay? So that is that. Next, let's consider example, let's see, example 6. Now for example 6, we are going to do part, no, give me a second here. Now to do example 6, which is on page 103. Okay, let me write that down here. We're now on page 103 and example 6. Now to do that, I will draw a line here. All right. Now, to do the example 6, let's refresh our memory about the cross multiplication principle. It says that if you have a number over another number, a over b, it happen to be equal to c over d. If that is the case, then you can cross multiply like this, and then the result will be the same. The formula says then a times d, okay, is the same as b times c. So that's how you will do. That's what you will do to get rid of the fractions. See, from going from here to here, suddenly the division lines disappear. That is why we do this. So having that in mind, we're going to apply that trick right here, okay? So that means we cross this way, 3 times x, okay? And then 5 times x minus 6. That will be equal following this rule. So that's what we're going to be doing. So we have a times d, okay? That's 3x on that side. And then b is down here, okay? B times c, which is x minus 6 times 5. And that equals to, so 3x equal to, well, the parentheses is on this side, but that changes nothing, okay? We'll take the 5, which is outside, multiply by each item inside, one at a time. It's like shaking hands with this group. We'll shake hands with each guy in here. So that will be 5 times x is 5x. And then 5 times negative 6, the negative sign sticks with this guy, okay? And so 5 times negative 6 will becomes minus 30. A negative and minus are the same symbol, okay? We call it sometimes negative, sometimes minus, they're all the same. So then we have 3x equals to 5x minus 30. So at this point, what I'm going to do is we'll push the 3x to this side because 5 is bigger. Okay, so we push the 3x to this side, that we get minus 3x. And then there's the 5x, which is a plus. Okay, if it doesn't have a symbol, it means plus. So we have that, and then we'll push the negative 30 to the other side so that it becomes positive 30. Anything you push a term across, that means that you change the sign. So that's a negative, I changed it to positive. And then let's add this stuff up, which becomes 2x equal to 30, okay? And the next step is we'll push the 2 down because this is being multiplied. So we'll push it down across the equal sign down below the division line. And so then x equal to 30 over 2, 30 over 2. And that is 30 over 2 is 15, and that is the answer. Okay, and your book might have done this slightly differently, but then they are basically the same thing. So having done that, the rest, there's a part B and part C to example 6, which are similar. Part B and part C have two fractions with x's in it. All you do is just combine those two fractions, and then it'll look exactly the same as part A, practically. So please do part B and part C yourself. And then with that, we'll move on to example 7, which is the most difficult one in this section, is that now we have 3 things with x's on the bottom. Okay, and how we're going to do that? Well, we're going to apply the same principles. But first, let me, I don't need to erase the board, really. We'll just start right here. So now let's do example 7. All right, we'll draw a line here. Okay, so now we're at example 7 on page 103 or something, 104, page 104. Okay, that's first I will write down the problem. Now before we do example 7, let's recall this formula which we're going to use all the time, which is the difference of squares, which states that a squared minus b squared equals to a plus b times a minus b. Okay, and this is extremely important. The reason I mentioned that is because this thing right here, when you take one look at this, you should remember that, oh wow, that's a difference of squares. And in fact, this thing is equal to x plus 1 times x minus 1, which in this case, what that means is this thing is actually the least common multiple, or whatever, the LCD, well, whatever it is that we can multiply, okay? Because if we multiply everything by this thing right here, that would knock out all the denominators in here and get rid of them all, so that our problem will become manageable. So that's what we're gonna do. Let's multiply x squared minus 1, okay, by all the way across. So everything will be multiplied by x squared minus 1. And remember, what is x squared minus 1? X squared minus 1 is x plus 1 times x minus 1. And that's what we're multiplying. So by doing that, then we, so let's write that down. So we'll multiply, we'll multiply by x plus 1 and x minus 1 for every single term here. Okay, now to do that, what that means is that, so when you multiply this thing with that, okay, that will cancel out this one. So that what we have left is 2 times x minus 1. Okay, when we multiply this thing up here, that cancels out the x plus 1, so we have x minus 1 left. Similarly, when we multiply this thing over here, we have cancel out the x minus 1, and we have x plus 1 left. So that's 1 times x plus 1, and then eventually 1, okay? And then eventually this thing, when we multiply this thing by that thing, then we have, this is the entire new denominator. So we have only 2x left. So that is how that will work. Remember, we're multiplying everything, okay? I should write a multiply, write a t there. So that's what we're doing, multiplying x plus 1 and x minus 1 to every single term here. It knocks out each denominator, and what's left is x minus 1 left here, x plus 1's left here, and then only 2x's left here, because that knocked out everything. It took everything to knock it out. So then now we have a much easier life. Is that right? Let me see. It's correct. Okay, I didn't see the minus 1 for a second here. But anyway, so we're gonna do this math to do the rest of the cleaning up. So this is 2x, multiply it out, 2 times x, and then 2 times negative 1. We have minus 2. And then minus 1 times x is minus x. And then minus 1 times plus 1, that's minus 1. And that equals to 2x. And at this point, what we're going to do is we'll put, let's see, 2x. Yeah, we'll put the x's on that side, okay? First, there are 2x on both sides. If you have the same thing on both sides of the equation, you can get rid of it. Basically, it disappears, okay? What you're doing is you're subtracting the same thing from both sides. So now we just have these things left. We have then, we'll push the negative x to the other side. That becomes positive, because when you push stuff across the equation line, when it's a then you change the sign, okay? And then, so that becomes x, and then, so down here we have minus 2, minus 1, so we have left with minus 3, and that should be the answer. Yep, it is. So that is the answer of to example 7, which is a and that should be the end of this section of part 1 that we're doing. However, I'm running out of time, so I'm gonna do the homework, which I want to explain in detail in a separate video. But right now, let's go back to page 99. Okay, flip back a few pages because I want to mention certain unusual rules. These are not things that you have to think about too much. It's just that sometimes that happens, and then you know what to do if it happens. So on page 9, let's go back to page 99. Okay, I want to talk about unusual cases. First, let's say you solve an equation, and the equation says is 3x equals to, what does it say? 2x plus x. Okay, now that looks like a very easy equation, right? And so what's 2x plus x? That's 3x. And then, so I have 3x plus equal to 3x. Like I said before, if they are on the both sides, then you can get rid of them, okay? So then if you get rid of them both, then what do we have? We have 0 equal to 0, and what does that mean, right? Well, 0 equal to 0, yeah, no kidding, but what am I trying to say here? Is what that means is this is a situation where you have no information. That is, in other words, x, it doesn't matter what you put in x, this equation will hold. Because 3 of anything is always equal to 3 of anything. So in other words, this equation has no specific solution because everything is a solution. Okay, so that is one special case. So then now another solution is something like this. Let's say we have well, I don't even need the book's equation. Let's say you're solving some equation, and then you have x plus 1 equal to 1 equal to x plus 2, let's say. Okay, you somehow ended here. And then as I mentioned before, if you have x's on both sides, you can get rid of it. So let's get rid of it. And what do we have left? Then you can have just proven that 1 equals to 2, which is bad, okay? What that means is that your equation has no solution at all, because 1 does not equal to 2 no matter what x you pick. And so then you have arrived at a problem. The reason this normally happens is probably because you made a mistake somewhere, okay? The same as here. If you end up with something like this, 0 equal to 0 or 5 equal to 5, that you probably messed up somewhere. But if you didn't, that would mean that your equation have solution that's everywhere, okay? Anything is a solution for it. Whereas this one, if you didn't make a mistake and you got here, that means your equation has no solution at all. However, normally this doesn't happen. I just want to mention it, so if you run into it, you know, you have an idea what's happening. But normally we don't deal with this kind of stuff in algebra, okay? Normally we just we have a good solution. That's what we're looking for, because this is not that interesting. So, but I should mention that this is possible, so that because sooner or later you're going to run into it and wonder what's going on. So that explains it. Okay, so for homework of this part 1 section where we do solving equations, please do problems. Let's see, where is it? Okay, problems 7, 9, 11, 13, 15, 17, 19, and 21. And then in the next video, I will talk about how to do them. So please do the problems carefully, okay? And make sure you know how to do these things, like inside out. And I will be explaining how to do them if you need any help for this, but in the next video, because I am running out of time. So this is the end of this video.